Hey guys, Mr. Milton here. Today we're going to talk about writing exponential functions. At the end of this video, you should be able to write an exponential function from a graph or from 2 points. So, what are two things that we need to write an exponential function? The answer for that is A and B. So, hopefully you remember now, A is the initial value and B is the growth/decay rate. Factor, let's say that. More than rate. Growth/decay factor. Okay, so those are the two things that we need in order to write an exponential function. And we can find those. So let's see how we can find them on the graph. On this graph, number one, we have a point here. Our point's at 0, 4. And we're asked to write the exponential function. Remember from our last lesson that our y-intercept is always our initial value. In this case, our y-intercept is at 4, so our initial value is 4. We can find out what our factor is by looking at our numbers as we go to the left and right. So this looks like -1, -2. Okay, and so I have a point here that's at -1, 2. So we can utilize our shortcut to find out what our growth factor is. Remember, our growth factor tells us what to multiply as we go to the right. So we went from -1, 2 to 0, 4. So as we went to the right one, what happened to our y value? It increased by 2, or not increased by 2. We multiplied it by 2. Notice that that's the same thing here. We had -2, 1. So from -2 over, we multiply 1 by 2. From 2 to 4, we multiply 2 by 2. And so our growth factor is 2. And so our function here is y, remember that's just a variable, equals a times b to the x. Okay, take a second, try the second problem. You can pause me and see if you come out with the same answer. So here, our initial value is 15. It's our A. And then we want to see where we move from there. So at 1, we're at 5. So again, we say, okay, what did we do moving to the right? We from 15 to 5. What did I have to multiply 15 by to get to 5? Okay. You might say, well, no, we didn't multiply. We divided by 3. Yeah, but remember that multiplication and division are the same thing. Just like adding and subtracting are the same thing. If we added a negative number, we're subtracting. Okay, if we multiply and get a smaller number, that means we're dividing. So we multiply by a fraction. So we multiply by 1/3. That is our growth factor here. In this case, sorry, our decay factor. And so we have A and we have B. We can write our function as y equals A times B to the x. And so there is our factor. Okay, exponential function, I'll just write this up here. Remember, that's the A times B to the x. Okay. So, now we've written the function from a graph, and we can do that. That's not too bad. And now we're going to write an expression from 2 points. Okay, so here are the 2 points. For this problem, we have 112 and 236. Gave you 2 points from the exponential function. Which letters do these represent? Now remember that this is a point, it's a coordinate, it's a location. These represent x and y. I know we've talked about a and b, but that means initial value and the growth factor. Okay, this is the location, it's x and y, and those are in our formula already, x, y. Okay, so if we plug these values in, we now have a system of equations. Except these equations are not linear, they are exponential. That means we have to solve them differently. So let's plug in our values. We have y equals, so here I'm going to say 12 equals a times b to the 1. Okay, so that's our first point, plugging it into our exponential function. And then we have 36 equals a times b to the second. Okay, and that's where this comes in. That's a 6, not a b. Alright, so how are we going to solve this? Here's how we'll solve this, and I really should have set it up differently. I should have set it up so the bigger number's on top, but I didn't, so we'll continue. Oh, I will. I'll set it up so the bigger number's on top, because I like that better. 36 equals, you could do it with the smaller number on top, but I think doing it with the bigger number on top just makes it a little bit easier to see. Doesn't change how we'll do the problem now. Okay. So, we have our system. Here's how we're going to solve. It's not a linear system, it's an exponential system, so we're going to have to solve it differently. And what we can do, instead of adding and subtracting to combine our system, what we're going to do is we're going to divide these two problems. Okay, I'm going to divide here. And so we get to use our exponent rules that we've talked about. We got 36 over 12, simplifies to 3. A divided by A, notice that that will cancel out. B squared divided by B to the first, we say, okay, is everything happy? Yes. Which one's bigger? The top, so we subtract by 1, and so we get B. So we divided that, and we got B to equal 3. Notice that the A's cancel out. Because of this, we can find the value of the other needed piece. Once you have that piece, you can plug it in and solve for the other. So we have that B is 3. And so now I can plug it into either of the equations, and I'll plug it into the top equation. 12 equals A times 3 to the 1. Okay, what's 3 to the first power? Well, it's just 3. So 12 equals 3A. Divide by 3, and I find that A is 4. Okay, so I plugged it in, I found that A was 4. So if I have A and I have B, I can write my exponential function as y equals 4 times 3 to the x. And that's our answer. Okay, and that's my exponential function. Okay. Alright, got a few other opportunities to do the same thing back here. I will try this time to make sure that I put the bigger number on top, because I like it that way. Alright, so as I look at these problems, I like to put the larger y on the top. Let's see how that goes out. So here, we'll set up this problem. We got 96 equals A times B to the third power. And we have 48 equals A times B to the second power. Okay. Remembering that we're setting these all up as y equals A times B to the x. And that's where our x and y are getting plugged into. Again, we can we can eliminate the a's and divide everything. So we have 96 divided by 48, that gives us 2. Okay. So we get b equals 2. Once we find that b equals 2, we can plug it into either of the equations. Doesn't matter which one. I'm going to plug it into the bottom one. Get 48 equals a times 2 squared. 2 squared is 4. So we have 48 equals 4a. Divide by 4. We get a equals 12. So I have b equals 2 a equals 12, I can now write my equation as y equals 12 times 2 to the x. Okay. Number 2, doing the same thing. I like to write the larger y on top, so I'm going to say 20 equals a times b to the 1. And I have 5 equals a times b squared. Okay, divide. 20 over 5 is 4. A cancels out. And so I say, which number is bigger? This one is. Okay, so 1 over b equals 4. Now remember, we don't want to know what 1 over b is. We want to know what b is. Okay, we can change this. Multiply both sides by b, gets b up top. So we have 4b equals 1. Divide by 4 to get b all the way by itself. B equals 1/4. Okay, so we found that b is 1/4. Once we have that, we can plug it in and find the other values. So 20 equals a times 1/4. Okay, so in order to find out what a is, we can multiply both sides by 4. And what that does is cancels that out. And so we get a equals 80. So we can write our equation, y equals 80 times 1/4 to the x. Remember, at any point you can pause it, try it on your own, and then see how your answer stacks up and your process stacks up to mine. Number 3. Okay, again, I like to put the larger y up top. 27 equals a times b to the 3rd over 3 equals a times b to the 1st. Okay, and so now we have 27 divided by 3, which is 9. The a's cancel out, and then subtract b. Okay, b squared equals 9. Now notice that when we're at this point that b squared is 9 and not just b. And so we need to find out what b is. We can do that by taking the square root of both sides. And in this case, we'll make sure that we keep our square root positive, so b is 3. So we find out that b is 3. Once we have that, we can plug it into either of the functions. I'm going to plug it into the bottom one and get 3 equals a times 3 to the 1st. So 3 equals 3a. Divide by 3. We find that a is 1. So now that we have a and b, we can write our equation of y equals 1 times 3 to the x. And then finally, this last problem. Again, I like the bigger number up top. 90 equals a times b to the 2nd power over 54 equals a times b to the 3rd. Alright. So as we do that, 90 over 54, that doesn't simplify all that nice, does it? 6 goes into both of those. 18 goes into both of those. Yep, 18 does. And so that simplifies to give us 5 over 3. Since I'm trying to simplify that. Okay. Gives me 5 over 3. My a's cancel out. Cool. And I get 1 over b. Okay, so if you noticed last time that when we had 1 over b, here, you'll notice that what we did was that for b to the negative 1, we had to take the reciprocal of the other side. Okay, we can math our way to that here as well. I'm going to get b to the other side, so I multiply both sides by b. 5b over 3 equals 1. If I'm trying to get b by itself, I'll multiply by the reciprocal, and I'll get b equals 3/5. Okay, so we find that b is 3/5. We can use that, plug it into either of the functions. I'm going to plug it into the top function because x is smaller, so 90 equals a times 3/5 squared. Remember, when we square this, we'll distribute that to the top and bottom, so 90 equals 9 over 25 times a. And so then I can figure this out by multiplying both sides by the reciprocal, 25/9. And on this side it cancels out, and so I'm left with a. On the other side I get 10 cancels out. I get 250. So a is 250. Alright, so we have enough information to write our equation now. Y equals 250 times 3/5 to the x. Alright, so there you have it. Writing equations from a graph and write an equation given 2 points. Might take some practice, but you have it. That is our exponents unit. See ya.